Summary, the Sino U.S. Rare Earth Dispute 2025 Analysis. Since mid-2025, China has tightened export controls on rare earth elements and refining technologies, citing national security and dual-use concerns. This move, coinciding with renewed U.S. China strategic dialogue, triggered global supply anxieties and price volatility. The United States, viewing rare earths as a foundation of clean energy and defense industries, has responded with rapid mobilization, launching domestic mining and refining projects, deepening partnerships with allies such as Australia, and expanding subsidies for processing and recycling facilities. China's leverage rests not merely on its resource endowment but on its industrial integration. It dominates every critical link: mining, chemical separation, magnet manufacturing, and recycling, thanks to decades of industrial policy and cost advantages. Particularly in the midstream stages of chemical separation and advanced magnet fabrication, China's expertise and environmental tolerance remain unmatched. The most strategically vital materials, neodymium, dysprosium, terbium, and europium, are indispensable for permanent magnets used in electric vehicles, wind turbines, radar systems, and precision weapons. These cannot be easily substituted or replaced within the next few years. Beijing's export restrictions serve multiple strategic purposes. Officially, they safeguard national security and prevent sensitive technology transfer. In practice, they are a calibrated economic weapon. By selectively restricting key elements, China can inflict pressure on global supply chains without provoking an outright embargo. Even temporary disruptions can inflate costs across defense, clean energy, and high-tech sectors, amplifying Beijing's bargaining power in trade and geopolitical negotiations. The United States and its allies are pursuing a three-track response. First, diplomatic diversification, securing long-term supply agreements with resource-rich partners like Australia and Canada. Second, industrial investment, subsidizing domestic separation plants and magnet factories under the Inflation Reduction Act and defense procurement programs. Third, technological mitigation, funding research into material substitutes, urban mining, recycling, and environmentally sustainable processing. However, most analysts estimate that building a self-sufficient rare earth ecosystem will take at least 5 to 10 years due to capital intensity, environmental approval delays, and the steep learning curve of chemical expertise. In the short term, up to 12 months, localized shortages and delivery delays are highly likely, forcing manufacturers to draw down inventories and seek alternative suppliers at higher costs. Over the medium term, 1 to 3 years, Western investments will begin to yield partial output, yet not enough to neutralize China's dominance. Over the long term, 3 to 10 years, a more diversified and resilient supply network could emerge, but complete desinacization of the rare earth chain remains improbable. For policymakers, the core recommendation is to balance speed and sustainability, accelerate facility construction while preventing environmental backlashes that historically drove such industries to China. Strategic stockpiling and government-backed purchase contracts can buffer short-term volatility. Long-term resilience depends on breakthroughs in separation chemistry, magnet alternatives, and large-scale recycling. For corporations, especially in the automotive, defense, and electronics sectors, supply chain redundancy is essential. Firms should lock in long-term contracts with multiple suppliers, co-invest in new refining projects, and redesign products for recyclability. Developing in-house expertise in materials science and recovery technology will also enhance strategic autonomy. The rare earth dispute exemplifies the broader fracturing of globalization into security-based industrial blocks. As both sides weaponize supply chains, costs of clean energy transition and advanced manufacturing are likely to rise. Yet, it also marks the beginning of a structural realignment, a world where technological ecosystems align not by efficiency but by geopolitical trust. In conclusion, China's integrated control over rare earths grants it enduring leverage, while U.S. and allied strategies aim to dilute rather than eliminate that power. In the next 5 years, dependence on Chinese processing will remain high, though vulnerability may gradually decline. The outcome of this contest will shape not only industrial competitiveness but also the future architecture of global economic security.